No, sorry. Let's just repeat that. So here the goal is to say that any two minimal generating set have the same cardinality. Okay. Yes. Once you have this, then it's very good. And it's very important to understand the proof also, as you can see. Right. So what we are doing is, so let S and S prime be minimal generating, and we are taking the other one to be just generating. I can take it to be minimal generating and the proof will still be okay. But if we just take it to be generating, then what we'll prove is a more general lemma, right? Generating. And the claim is that cardinality of S is cardinality of S prime. And it is homework that this claim implies the lemma. It is a simple homework. Claim implies stuff. That I'll not talk about now. Yeah. So this one. Yeah, that is why I proof usually don't give the other. Let me write another lemma, which I will assume. Again, just changing it a little bit. And this will be that, so if you have a m by n a m by n x equal to 0, this equation, system of equations, okay, has a non-trivial solution if m is less than n. Okay, right? So if you have less equations than variables, then you will have a non-trivial solution. Okay. Why is this true? Because this a m by n, this you can just, I'm just writing like this, we're highlighting this fact that m is less than n. When you write it, imagine that you reduce it, row reduced echelon form, whatever, right? I cannot really say this is 0, but you see, you reduce it, right? Then, I'm sorry, yeah. If you reduce it, even in the best situation, you reduce it like this, what is the point? Point is you will have free variables because there are more columns than rows, right? This is the best situation, right? Point is there will be some free variables, right? This star, star, star. Right? So what does it mean? It means that this variable w is free, and so it can take any value. So it implies it will have non-trivial solution. Is this argument okay? You can write it as a proof.
Can you write the matrix in a little form, like 4 cross 4 or 4?
Yes, yeah. So that's what, right? So if you write it as 3 cross 4, just take the simplest non-trivial case, 2 cross 3 is also fine. I don't mind it. If you write it as 3 cross, so if you have a 3 cross 4 mystery, that is what you have to try when you back at home, right? After the class, I mean. when you take 3 cross 4 matrix and you do row reduced echelon form, you will have a column which will not be a pivot column. You will have a column in which you won't have, right? That column will not have this kind of one. Agree? Okay. So every row has this has a leading one. Every non-zero row has a leading one, which is called a pivot row, which is the pivot of that row, and corresponding to that there's a column, right? But 3 rows can only contribute to 3 columns. And then the 4th column, we can really not say anything. It could be 0, 0, 0 also. But what does this mean? This means that your system will be something like x plus star w equal to 0, y plus star some any number, it could be 0 also, I don't care, z plus some other star w. You see there are infinitely many solutions, both of you, right? See that this w
Yes,
can take
yes.
any value, because yeah, because it's in front of you, right? We have also written the solutions in the past. So this is you have to do, and I will suggest you to read more seriously. So note this down, because I cannot say all these things. These are simple things also. So what you do, you now go to Hoffman and Kunz. Okay? Hoffman, you borrow these books from the library if you are going to library. Otherwise, you read it, or just buy. You can buy Indian edition is there, Pearson is there. So Hoffman and Kunz, please read it. Artin doesn't do it as well, I think. I think Artin doesn't do that as well. Chapter 1, then ideally you can do all the things, but yeah, I think you should do, because it's very important. So section 1.2, 1.3, and 1.4. I'm just giving 3 sections. The other 3 sections are not giving. These 3 sections is mandatorily read. It will be easy read, and you should read and solve the problems and ask me if you cannot do something. Okay. I'm not going outside and outside. This is important. So then I can suggest some interesting questions. Otherwise, it will be difficult. Cool. Let's see if we can use.
Sir,
Yes.
I couldn't get the previous solution
Yeah, that's what I'm going to discuss.
models. Okay.
That's what I'm going to discuss. This I'm just changing it up. This will come up. So yeah. So sorry. Yeah, maybe. But please do this. Hoffman and Kuhn's linear algebra. 1.2, 1.3. Erasing. Okay, let's take a breathe for some time. Think of this as a very simple lemma. There are more variables and less equations, so you will have a solution. Because 0 is on the right side. There is no other option that, yeah, some row will be 0 and that side will not 0. Those things. Let's see if we can use this lemma. Then it will be nice. Okay. So let us see that, let's say that the size of this thing is n. And let's say that the size of this thing is n. Okay. So the generating set size is the n, m, and you can understand why I'm writing like this, so that you can use this lemma without changing anything. So now if you write S1, same thing I'm writing. Sorry. Yeah, that will work, but I want to use the lemma. So then you um uh, yeah. Change no notation little bit and what. So let us right. I mean, I don't need to think so much, right? If it comes, it will come because everything is set. Because thinking more here, I don't think. So you write this. So you see here, you understand, right? This SIs are vectors. They are some abstract vectors. Uh, yeah. Let me just keep it like that. Say just say that much. And then this S2. Yeah, last time I didn't do a good job explaining it. It's the first time I'm doing like this formally, like this and so on. And then you have Sn. Nm, right? Yes. Okay. So yeah. So this is the situation, and yeah. Let me write this in this form. Okay. This thing I will write as a column. C11, C12, Cmm. I will write as a column. Okay. So we will read like this, right? That this gets multiplied with this. Is it fine? And you get the first row. And similarly, yeah. So we are reading this multiplied with this. That's going to be the, it's the same thing. Okay. Both of you, do you see that this is okay? The same thing.
Yes, sir.
With the interpretation I'm telling, it's the same. But these are not numbers. These are all of them other. But it's fine. And just understanding that mutual understanding they are making. Right? And this is it's kind of. So I erase this. Now, if you apply the lemma, so now if m is less than n, then what happens? If m is less than n, then what happens? If m is less than n,
Then
then
we will have m
non-
growth. We will have an, if we do row reduction, we will have
yes,
identity matrix for till mth row, and then there
then
would
we'll
be
have some zeros. Exactly. But now you don't need to say that. That is mathematics. Now that is encoded in this lemma. You can feel that row reduction argument is put in this lemma now. It has gone into proving this lemma. So we just need to use this lemma. We don't need to invoke that argument again. Okay? That is, मतलब कि properly keeping things. Then you don't have to use that. That's all we do in mathematics. So how do you now just use the lemma, and you can know that I don't need to use the row reduction argument again because it has gone into the lemma. So it means that there is a non-trivial solution. So there is a non-trivial solution. It means that there is a column, right? There is a column which is non-trivial, which means that all the things are not equal to 0. All the things are not equal to 0, right? And this thing is equal to 0. Cool. It has gone into the lemma. That's what I was thinking, to make this thing easier so that I can explain it. Okay, right? And so just focus on the right hand side. This becomes 0, 0, 0. These zeros are not numbers. These zeros are vectors. Correct? Right? Because you take this vector and you take linear combination with these coefficients. That is what this means. Okay? That is the understanding we made, right? And obviously we have associativity. This thing, right? You do this thing and then you apply this thing is same as this thing and then you apply this thing. That will be true. Our understanding is number one, but checking this associativity is number one, which I'm not even leaving as a homework because you know it will be true. And that associativity comes to play. Associativity always comes to play. Is the thing that's working in the background. Okay. So you get this zero vectors, or no, sorry, this is wrong. Yeah, so you take linear combinations, right? So you take S1 vector with 0 coefficient, S2 vector 0, so you get the 0 vector. Right? You get a single vector. With the 0 vector, so it means that this is a 0 vector, right? Now what is this? This is x1 times S1, x2 times S2, and xn times Sn. This is a 0 vector. And all the xi's are not 0. At least one of them is non-zero. That's what non-trivial solution is. So you see that some linear combination is equal to 0. But you did as homework that this is linearly independent set. Minimal generating is linearly independent, so it cannot happen. So that's a contradiction. And so M is at least.
how C11, C21 multiplied with x and we getting 0?
That is by definition. That is the property of this x1 up to xn. So see the lemma. Aryan, can you explain why this thing is 0? Aryan is here. Okay. All right. No problem.
Yes,
Yeah,
yes, sir. It's just that like I'm having internet issues today.
Okay. Yeah, no issues. So do you see why this thing which I've circled is equal to 0? It is why this thing, why this lemma, right? That x1 up to xn exists from the lemma.
Yes,
Right? That,
yes, sir.
Arnav, is it fine?
Yes, sir.
Still no.
Okay. So that's the thing.
What does the lemma says?
Yeah, you read. Lemma says that if you have a matrix m by n and uh, uh, yeah, it's m by n and n is less than n, then it will have a non-trivial solution. Right? Non-trivial solution means what? Means that there will be some vector, sorry, x1 up to xn non-zero such that it will be 0. Correct?
Got it. Got it.
Yeah.
Got it. Got
And
it.
that is what that's the thing. That is the whole thing. Okay? That is nice now. Proof is good, right? Simple. Now it is simple. When you put it in that,
It's gives us zero vector. It's okay. Then the last line.
uh-huh. So the right hand side, so this one gives you a 0 vector, right? So this is 0 vector. And this, how do we read this? We read this as taking linear combinations, right? Because S1 prime itself is a vector, right? S1 prime is a vector. And so this notation means that you take 0 times this vector, means 0 scalar is 0, 0 times this S1, 0 times this 2 prime, 0 times S1 prime, and you add them. But obviously that is 0. But this is a vector. But that is the understanding we made. This is not the usual matrix multiplication. This is our definition. That when you have a row of vectors, everything is a vector, and you have a column in which everything is a number, and that multiplication means taking linear combination of the vector with those corresponding entries. That understanding we made, and then it comes to 0 vector. And the left hand side is this combination x1 s1 plus x2 s2 plus xn sn equal to 0.
Okay.
Correct? So this is the 0 vector, but S1 up to Sn is a minimal generating set. And minimal generating set is, by your homework, a linearly independent set. So it cannot happen.
Okay. Okay. So yeah, and the lemma says it would be non-trivial, but we are getting x1, x2, 0. And there is the contradiction.
Exactly. X1 up to Xn is non-trivial, which means that some xi is not equal to 0. And then we have a linear combination that's equal to 0. But you showed that minimal generating set is linearly independent. Correct? So all the things come to play, and you get your most useful theorem to just prove this exercise. Look at this carefully. Okay, look at this carefully. Take a break. Okay, let's take a break and meet again, and maybe some 15 minutes we can do other previous days wrapping up. Okay, yeah, from the cardinality questions. Let's wrap that up, and maybe if we can, we will prove this thing for when S and S prime have infinite cardinality. We'll try to show that the cardinalities are same. Let's see. Can mix up, right? Previous day's thing and today, and they show for infinite dimensional vectors there's also the cardinality of bases. Let's see if we can do it. Okay. So Aryan, we are just taking a break for 5 minutes and then we will meet. Hopefully Zoom will not again add the
Yes.
time used of now and that. I don't know what it will do, but yeah.
Yes, yes. Yes, sir.